Hi everyone, just wanted to take a minute to talk a little bit about special right triangles. Again, we're going to this time be talking about the 30, 60, 90 special right triangle, which is the second type of special right triangle. And we'll talk a little bit as well about where this one comes from. So the last one, if you recall, was the 45, 45, 90 triangle. It came from when we took a square, we cut it in half, and it had two angles that were 45 degrees and then the right angle. It was relatively straightforward. This one is a little bit more involved, but it's still not too bad. So we're going to be using these right triangles to determine some side lengths, and then we're going to use that to derive, well, before we do that, I should say, we will derive where the 30, 60, 90 triangle comes from and what its relationship is. All right. So what exactly is a 30, 60, 90 triangle? Well, it's in the name, right? So if we have a right triangle where we have one angle being 30 degrees and the other angle being 60 degrees, that is a 30, 60, 90 right triangle. So it's directly in the name, right? You have an angle that's 30, angle that's 60, the other one will be 90. And you can probably, just from identifying this and looking at this for a minute, you can probably see that there is going to be a pattern that's going to emerge, as you can guess. Now, where does this come from? Well, imagine you took an equilateral triangle and you cut it in half. All right? So what do I mean by that? We drew an altitude. Okay? So for if you remember from way back when, isosceles triangles, you'll have the altitude here. It's going to cut things in half. You'll get a lot of bisecting, I should say. So this is going to be like this is the same as this. This angle is the same as this angle, right? So that's where it comes from. We draw an altitude. We get a 60-degree angle, or we always had one, I should say, and then we get the 30-degree angle from the 60 angle getting cut in half, or bisected, I should say. And then just from this piece of information down here, right, we know this is half of the whole thing. So whatever the hypotenuse here is, it's twice whatever this is, right? So if I had like this was x, this would be 2x. And then from there, we can go through the process and solve for the other side. So if we go through that process, right, this is my hypotenuse. I'll call this b. All right, let's call that b for now. All right, so we have 4x squared is equal to x squared plus b squared. I'm going to subtract the x squared. I'll get 3x squared is equal to b squared. Take the square root. Root 3x squared is equal to b. B is equal to root 3 times x. All right, so much like the other one where we had a root 2, now we will have a root 3. All right, so in general, when you are looking at a 30, 60, 90 triangle, the side opposite the 30, the short side here, will be just, this is kind of your reference side, right? This was the part that was bisected. This was half of the full side length, right? So the opposite of it. We're just going to call it A, you're going to call it X. It's your reference side. It's whatever the base side is, right? Like before when we had the two legs on the 45, 45, 90, right? They were just X. So that's kind of where we're starting. The hypotenuse is twice that. Okay, so remember, this comes from an equilateral triangle, so all the sides were the same, except when we bisected one of the sides, that gave us the 30, the side opposite the 30, which is why it's half of the hypotenuse. All right, and then from going from the Pythagorean theorem, the side opposite the 60 will be your 30 side times the square root of 3. Okay, so what do I mean by this? I mean, like if this is 5, this is 10, this is 5 root 3. If this is, 2, this is 4, this is 2 root 3. Okay, so it's really helpful to know what the side opposite the 30 is. All right, so let's do some practice with this. There's really nothing else to it, it's just practicing with this. So here we have the side opposite the 30, so that's good. That's essentially our A, or our X, if you will. So I'll say A is equal to 5. We know over here the hypotenuse is double the side opposite the 30. So that means this is double 5, which is just 10. That's it. That's all there is to that one. Just 10. Similarly, here we know this is the hypotenuse. Okay? So that means this is twice the side opposite the 30. Okay, so this is twice whatever this is. So if you divided this by 2, you get 1. Okay, divide it by 2, you get 1. Now, if this is 1, this is the 30, you know the side opposite the 60 here is whatever the 30 side is times the square root of 3. So I have 1 times the square root of 3, which you don't even need to write the 1, so it's just the square root of 3. Okay, so if you do not have the side opposite the 30, that's my recommendation to you. Get that side, because that side will help you out greatly with pretty much everything. Okay. Now, when are things going to get a little bit tricky? Things are going to get a little bit tricky when you start getting things with radicals, or you potentially have to solve for certain sides. So in this case, we're given that the hypotenuse here is the square root of 8. Before I do anything, I do want to simplify the square root of 8. I don't like that it's there. Right? We know to simplify that, right? That's the square root of 4 times the square root of 2, which is 2 times root 2. Now, I think when you see it written out this way, it makes your life just looks better. It looks better, right? Because this is the hypotenuse. And we know the hypotenuse is 2 times whatever the side opposite the 30 is. Look, boop, I got 2 right there. So it's just 2 times the square root of 2. So what does that mean? Well, that means if I divided this by 2, I would get that x is just going to be equal to the square root of 2, right? So that one, it looks harder than it's going to be because it gives you the square root of 8. But if you simplify the square root of 8, you know you have 2 root 2. And this is just, whatever your number is times 2. So bam, right there, there's my x. Okay, so always look for those shortcuts if you can. Now, same thing. We're going to go through this process, but now we have to find the other side, which is a bit of an annoyance, right? So we did just find that this was equal to the 2 root 2, which meant that this was root 2. Now, we know that the 60 is equal to the 30, the side opposite the 30, times the square root of 3. So x here is going to be equal to root 2 times root 3, which is just going to be root 6. Okay, so my big recommendation to you when you're doing these out is always going to be solve for the side opposite the 30. That's kind of your starting point, right? Because if you know that this is, root 2, multiply this times 2, you get the hypotenuse. Multiply it times the square root of 3, you get the side opposite the 60. Okay, and just like before, if you end up with something where you potentially need to divide by a square root, you know how to rationalize. All right, let me know if you have any questions, and have a great day.